we are going to discuss motion in a vertical circle. So whenever there is a motion in a vertical circle, so what does it mean?
The circle is then horizontal, like we discussed in previous cases.
Yeah, in
It's
previous
like,
case we discussed that circle is like a horizontal circle. Now you are just tied a rope into your hand and other end is tied with a mass, okay, with a body, and you're just rotating it like this.
like this.
Yeah, okay. So you are making a vertical circle this time, okay. So we'll discuss that. So you know energy is conserved, conservation of energy. That means it is just changing its form from one form to another form, okay. So by that principles we'll find the velocity and all, whatever is the velocity at which point, okay, what is the tension at the highest point and at the lowest point, what will be the velocity at the highest point and what will be the velocity at the lowest point. So these things we are going to discuss today in this lecture, okay. So just focus here on this figure, okay. Is that clearly visible?
Yes.
Okay. Don't do anything, please be focused here. Okay. So let us say this is your body is just tied and that is in motion and it is making a circular motion vertically, okay. So we are talking for this particular point P. At this particular point P, how many forces will be there?
Particular point P. There would be the tension.
Tension will be inward,
Yes.
okay.
There
And
will be
mass, weight,
yeah, the
weight,
G,
weight will be downward.
yeah.
If this angle is theta, so this component of mg will be mg cos theta.
Yeah.
This one will be mg cos theta and that one will be mg sin theta.
There will also be component of tension, right?
No, tension is always towards fixed point, okay. It doesn't have any, because tension is always
In the straight.
yeah, so that doesn't have components, okay.
Okay.
So these forces will be balanced. Let us say the height of this from the lowest point is h. This height is taken as h. So that is the height from the lowest point at this point P, and let us say the radius of this circle is r, small r. So if this is the height, that will be r minus h,
Okay.
okay. So now T will be equal to mg cos theta,
Yeah.
and what is another force?
T is equal to
T and mg cos theta will balance each other, but because of their unbalance, what will happen?
there will be another force.
Which force? First of all, we'll try to find its velocity at this point, okay.
Yeah.
So we'll find its velocity at this point. How we can find velocity at this point? Just we'll use law of conservation of energy, okay. By the law of conservation of energy, what happens? Energy at all point will be equal.
Yeah.
So according to the law of conservation of energy, now what is kinetic energy at L?
Kinetic energy at L.
Yeah, let us say its velocity is u at L, Okay,
Okay.
its
Half
velocity,
mv square.
yeah, so it will be half m u square.
Yeah.
Okay, plus how much is the potential energy?
Mgh.
There is no height because it is at the lowest point,
So 0.
0, and the potential energy at this point P,
Height will be mgh.
mgh.
So, but how do you know conservation of energy will be applied here?
Everywhere it is applied, but you have to practice it, because I told you earlier, conservation of energy and the free body diagram both will work here. Okay,
In everything, vertical, horizontal,
yes,
even horizontal circle.
yeah, if it is required, then we'll apply it.
Okay.
Okay, so how much is the kinetic energy here? Mv square.
Yes.
Okay, cancel from both sides. We need to find that V. So how much is V? So V square equal to U square minus 2GH, isn't it?
Yeah.
So V will be U square minus 2GH under root. So that will be the velocity at the point P. If the body is passing at the lowest point with the speed u.
Yeah.
Okay. Now we'll apply the concept of what? Concept of centripetal force. As it is a circular motion, so centripetal force will be into the picture,
Yeah.
and this T and mg, because of difference in T and mg cos theta, there will be a centripetal force. Okay?
Because of a difference between them.
Yeah, because of a difference. If they are equal, there will not be any force.
Yeah, and it's interesting because tension is more than mg cos theta, right?
Yes, you are absolutely right.
Because if mg cos theta is more, then it would move outward.
Yeah, the string will detached.
Yes.
Okay, tension must be more.
Yeah.
Okay, so that means T minus mg cos theta will be equal to centripetal force.
Yeah.
It is understood or not?
Understood.
Okay, what will be the value of cos theta? We can calculate from there.
Yes.
Cos theta is how much? It is base upon hypotenuse.
Yeah.
So that is r minus h upon r. Isn't it?
Minus h upon r. Yes.
So cos theta here will be r minus h by r, because this distance is r.
Yeah.
Okay. So now just put the value of v square as well as cos theta into this equation. So that becomes T minus mg cos theta is r minus h by r equal to m into v square is u square minus 2gh, u square minus 2gh divided by r. Got this one?
Yes.
Okay, just we are going to solve it. So we need to find T. So T equal to m, I can take it common, m by r. Okay, m by r from this, m by r from this also,
Yeah.
isn't it? So here it becomes u square minus 2gh, and here it will be positive there, so it will be gr and minus gh. Is it understood?
Yes.
So that T will be equal to m by r u square plus gr minus 3gh. So that will be the tension in the string.
Okay.
Okay. So that will,
So-
yes.
Will there be ever be a case in which we need to apply friction or pseudo force or something like
Yeah,
that.
then scenario will be different. Here we are thinking that it's an ideal situation.
Okay.
Okay. So now tension in the string at the bottom and the top we'll discuss. So this formula, just write it down. We'll discuss it accordingly.
Yes, sir. Should I draw the circle? Should I draw the circle?
Just write down the formula only.
Okay.
Just write down the formula and we'll discuss all the scenarios. How much tension will be at the top, how much tension will be at the bottom. That thing we are going to discuss here. Okay?
Okay, sir.
Can you tell me in a layman language where will be the tension more? At the top or the bottom?
The top.
Top.
Yeah, at the top. At the bottom there'll be. Oh, sorry, at the bottom, at the bottom, at the bottom.
Okay, good.
Because the string will be stretched out into mg.
Okay. Should I remove it?
No, sir. No, sir.
If some of your friend from mathematics want to learn something, then you can refer me.
Sir, definitely. Yes, sir, then writing.
Okay, done?
Yes.
Okay, so we are going to discuss now what will be the tension at the top and what will be the tension at the bottom. So the formula is T is equal to m by r u square minus plus gr minus 3gh. That was the formula
Yes.
for tension at any moment. So tension at L, L means at the lowest point. So TL, what will change at L?
Change at L.
U will be U,
Yeah.
G is not going to change, R is not going to change. What will change? Change will be in the height.
Height.
So at L, height will be 0.
Yes.
So that will be equal to U square plus GR. So that will be the tension at the bottom. Got it?
Square plus GI. Okay.
Now tension at H, this point. So TH will be M by R
Which is R.
U square plus GR
Square plus
minus 3G. How much will be H?
That's what I was thinking.
Very simple here. This is R. This
Okay,
is
this is 2R, sorry.
2R.
Diameter.
2R. Okay.
Yes.
So how much it should be? U square minus 5GR. Okay. That shows that tension at H point will be lesser than the tension of lower point.
Yes.
Okay. How much will be the difference? TL minus TH. Question asked based upon this. TL minus TH is M by R is common. U square plus GR minus U square plus 5GR. U square cancelled. So that becomes M by R. 5GR and GR is becoming 6GR. RR cancelled. So that is equal to 6 mg. Okay.
Yes.
So the difference of tension between the lowest point and the highest point is 6 mg.
Yeah.
Okay. Now we'll discuss minimum velocity of projection at the lowest point for looping the loop. It may be possible that it doesn't have the velocity that it crosses that H point.
Yeah.
The loop may end. Okay.
Yeah.
So when it will be happening? Once your tension is 0.
Yes.
So to pass that H point, your tension must be
See.
greater than or equal to 0.
Even equal to 0 is okay.
Yeah, equal to 0 is also okay.
Okay.
Okay. Because by the Newton's first law, it is in motion, so that will keep continuing in motion. Okay.
Yeah.
So that means if TH is greater than or equal to 0, so if you put in this formula, what that become? M by R and U square minus 5GR greater than or equal to 0. M by R will go 0. So U is greater than or equal to 5GR square root. Got my point?
Yeah.
So that will be the minimum velocity to continue that loop. Okay. Question is asked upon this concept. Minimum velocity of the body to continue its loop.
So can you explain this again?
See, the body will fall if there is no tension.
Yeah.
So the tension must be greater than or equal to 0.
Yeah.
Okay. So at height, at H point, tension is M by R U square minus 5GR. Okay.
Yeah.
So if I put this TH into this condition, so that is the condition to have its loop continue.
That's the minimum tension it should have.
Yes.
The minimum tension it should have to continue the circle is the tension it has at the highest point.
it should be greater than or equal to 0. It can't be negative.
So
Okay?
you're saying the tension at the highest point will be 0 every time?
No, tension at this point will not, every time it will not be 0.
Okay.
Okay? There may be
Okay,
some,
when it's 0, it will not continue.
yeah. At 0 it will pass, but if it is lesser than 0, then it will fall down. Okay?
Okay.
So,
Okay, okay.
so that is the minimum velocity required to continue that circle. That is, u must be greater than 5gr square root.
Okay. You should be greater than this value if it wants to continue.
Yes. Okay?
Okay, sir. Did you receive the document which I sent you yesterday?
Yeah, I have seen it. We'll discuss it.
Was there anything new inside of it?
Yeah, everything. Everything is based upon this.
No, because I think there was centrifugal and those forces as well, right?
Yeah, centrifugal is just a virtual force. It is not existing. Okay? It is just one kind of imaginary force. So don't focus centrifugal force. Just focus it centripetal force.
Okay. There are some questions based on that as well.
Okay. We'll discuss it. No issues.
Yes.
Now you know we had previously v square equal to u square minus 2gh.
Yeah.
That gives you the velocity at any point. Okay.
Yeah.
So what will be the minimum velocity at the top?
Minimum velocity at the top.
Yeah. So so minimum velocity at the top will be given by u square minus 2g. At the top, h will become
0. Sorry, 2R.
2r.
Sorry.
So that will become u square minus 4gr. Okay.
Yeah.
So that will be the velocity, but we are talking about minimum velocity. Okay. So minimum velocity means u should be the minimum. What is the minimum value of u?
Can be
5gr.
5GR, yeah.
It can be equal to 5gr. So 5gr minus 4gr, that will give you gr. So that is the minimum velocity at the top. It should have, so that it will continue its circle. Okay. So these are two conditions. That will be the minimum velocity. Okay. And that will be the minimum velocity at the top to continue it as a circle. Okay. So that you can say it's a critical velocity. Okay.
Yes.
Now what happens if u is lesser than 5gr square root?
It will fall. And it will stop when it will come down.
It will come down. The body will either oscillate about the lowest point L or will leave its circular path. Okay.
Yes.
So either it will fall down and it just oscillate. Okay.
Okay. Yes, I'm done.
Done?
Yes, sir. I just close the window.
Okay, should I erase it?
Yes, sir.
Okay. Okay, so now we'll discuss about conditions for oscillation. So there are two conditions in which the body can fall and it will oscillate.
Yes, sir.
So there are two possibilities. First possibility is that body will leave the circular path or it will drop and oscillate about the lowest point. So first of all, the first condition we'll see, that is oscillation. Okay.
Okay.
So what will be the condition of oscillation? Okay. So suppose the velocity of the body becomes 0 at the height h.
Yeah.
Okay. First of all, u must be lesser than 5gr square root. Then only these two things will happen.
Yeah.
Okay. Okay. Now we are supposing that its velocity at h becomes 0.
Velocity at h becomes 0.
0. Okay. Suppose the velocity of the body becomes 0 at height h1. Okay.
Yeah.
It is not going up to the highest point. Suppose the velocity becomes 0 at some certain point. Okay.
Yes.
So we have read that u square v square equal to u square minus 2gh. So velocity of the body is becoming 0 if v is 0 at h1 height. Then what will happen? 0 will be equal to u square minus 2g h1. So that h1 will be equal to u square by 2g. Got my point?
No.
No. Suppose before going to the highest point, its velocity becoming 0.
Before going, it becomes 0.
Yeah, it
Okay.
can happen.
Yeah.
Okay. So we just put 0 into v. So if we put 0 into v, height as h1, so your height will be u square by 2g. That means at this height your velocity will be 0. Okay.
Okay.
Now we just think another scenario in which your tension is becoming 0 at height h2. Okay. That is scenario 1. Scenario 2, let tension becomes 0 at height h2. If tension becomes 0 at height h2, what was the formula? Formula of tension was m by r u square plus g r minus 3gh. That was the formula.
Yes.
Okay. Now your tension is becoming 0 at height h2. So just put that value into this. So T is equal to 0 m by r u square plus gr minus 3g h2. So you can easily find h2 from this expression. So your h2 is u square plus gr divided by 3g. Got it or not?
1 second. understood.
Okay.
Yeah.
Now,
These are also applicable for the highest point, right?
no, we're not talking about highest point. There may be a scenario here your tension becomes 0.
Okay.
Here your velocity becomes 0. Okay.
But like, understood. It will be the same, right? But I don't understand. It will just be the same even if it is the highest point.
We are just assuming that it is leaving its path.
Yeah.
Okay, so there may be two scenarios. Either it is dropping down
Okay.
or it will oscillate, it drops and oscillate along lowest point. Okay. So, now the condition when the body will oscillate if the velocity becomes 0 earlier than the tension. Okay. So, the condition of oscillation is velocity becomes 0 before tension. Just note it down.
Condition for
Oscillation. Velocity becomes 0 before tension. Okay.
Okay.
So, in that scenario, what will happen? What will be the relation between H1 and H2?
Between H1 and H2. What do you mean relationship?
Your tension becomes 0 after your velocity becomes 0.
Yeah.
That means you will achieve more height. That means H2 will be more than H1.
1 second. Velocity becomes 0 after tension. Yes, so velocity will, H1 would be higher than H2.
No. H1. H1 is the height at which velocity becomes 0.
Yeah, because velocity becomes 0 before tension.
Before tension it is becoming 0. So, H1 will be lesser than H2.
Yes.
H1 will be lesser than H2. So, just we'll establish that relation. U square by 2G is lesser than U square plus GR divided by 3G. Okay.
Yes.
So, now how you will solve that inequality? GG cancelled. 3U square, 3 will be multiplied here. 2U square plus 2GR. Okay.
Yeah.
So, U square will take that left side. So, it will be 2GR. So, U square will be lesser than 2GR. That means U will be less than 2GR square root. So, that is the condition in which the body will oscillate about the lowest point.
Okay.
Okay. So, that is the condition in which body will oscillate about its lowest point. Okay. What will happen if U is equal to 2ZR? The path of the oscillation will be a semicircle.
Can you repeat, sir?
What will happen if U equal to 2GR?
U is equal to 2GR.
Then just remember it, your path will be a semicircle.
Will be a semicircle.
Yeah. Okay. So if u equal to 2gr, then the path will be a semicircle. Okay.
Okay.
That means it will go and come.
Okay.
Got it?
Will it continue to oscillate in a semicircle or will it
Every
stop?
time it will not be a semicircle, because the first one will be a semicircle. Okay? Because so many things will come into the picture, so many forces will come into the picture. So its oscillation height will always be changing. It is slowing down every time. Okay?
Yeah. And so shouldn't it be negative 2g? U square divided by negative 2g in h1.
Where I divided it?
h1 is equal to u square divided by 2g.
It is not negative.
No, it should be, right?
Why it should be?
Because it's negative 2g over there.
U square, just keep it there, yaar. It is just a simple calculation. It is 0 equal to u square minus 2g h1. So that
Yes.
h1 will be equal to
Okay, sorry. Yes, H
H1.
cancelled, okay.
h1 will be u square by 2g.
Yeah, it will get cancelled. Negative u square and sorry.
Okay?
Yeah.
Okay, so now what will be the condition for the body to leave the circle?
It should be greater.
Yeah, so that means h2 will be lesser than h1.
H2 would be, can you repeat?
h2 will be lesser than h1.
Yeah. H2 would be lesser than H1. But isn't it always lesser, sir?
No, it will not be always lesser. That is the condition, yeah. So if your h2 is lesser than h1, that means what? That means tension becoming 0 before velocity.
How if H2 is lesser than H1, tension is becoming 0 before? What?
What is the condition if tension becomes 0? Tension becomes 0, the tension is becoming 0 at height h2.
Yeah.
Okay, if h2 is lesser than h1, then what is the meaning of this? That means tension is becoming 0 less before that velocity becomes 0.
But sir, if H2 becomes, H2 is, okay, H2 is less than H1, okay.
Okay,
Okay.
so that will be the scenario when the body leave the circle. Just have you noted down it?
No, sir, 1 second. Done, sir.
Okay. Okay, done.
Yes.
Okay, the second scenario, body to leave the circle. What happens if the body leave the circle? Here it is u lesser than 2gr. Scenario will be different. Here h1 is lesser than h2 and that scenario h2 will be lesser than h1. So that condition will be u will be greater than 2gr. So that will be the condition when body will leave the circle. Okay?
Yeah.
Body will leave the circle. And that time your tension will become 0 earlier than the velocity becomes 0. Okay? Got my point?
Okay, so if it's less than, if u is less than root 2g, the body will oscillate about its position.
Yes.
And if u is equal to 2g, then the path will be a semicircle.
Yeah.
And if u is greater than 2g, it will leave the circle.
Yes.
Okay, because it can break the tension.
Yeah. Okay.
Okay. You only know that much, right? U is greater than 2g.
Yeah.
Done right.
Okay, so you remember the last time we did u greater than 5gr?
Yes.
Okay, so if your v is in between 2gr and 5gr square root, vl in between 2gr square root and 5gr square root, then what will happen?
Once again, sir, I don't understand.
It
What
will
are you saying?
it will leave the circle if vl is greater than 2gr but is lesser than 5gr.
Greater than 2gr but lesser than 5gr.
5gr. Then it will leave the circle between h and m. It will cross h but will leave the circle between h and m. Okay?
Okay. What is VL, sir?
VL is the velocity at the lowest point. Okay?
Velocity at lowest point.
Yeah.
Okay. And
So this is the condition in which body will leave its circular path between h and m, will follow a parabolic path, and then again a circular path. Okay?
yes.
So that is the special condition, just write it down.
1 second, sir. It will only live between H and M.
Yeah.
Okay. And what happens if it's greater than 5 GR? Then it won't leave.
It will just, if it is greater than 5 GR, then what will happen? It will continue its motion.
Okay.
Okay. But if it is lesser than 5 GR, then it will leave for some time, but it should be greater than 2 GR.
What is the exact meaning of root 5G and root 2G? What does it signify?
R is, what is R? R is the radius of circular
Yeah.
path. G is constant.
So, what are they exactly?
This is exactly an expression.
Okay, it's like nothing. It's not like a value.
No,
There's no meaning.
it's not a value. It is just an expression. Okay.
So, we never derived 5GR in itself. We only derived things like u square minus 5GR and things.
Yes. We didn't derive it. Just so for the body to leave the circle, that is the condition. Okay.
Okay. But I don't like that minimum velocity at the top, right? That's why we were writing v is equal to gr.
Yeah.
So why will it leave if it has minimum velocity at top v is equal to gr?
That we discussed earlier here. Minimum velocity at the top, it is gr square root.
Gr square root? No, we
Yeah.
did v is equal to gr, sir.
Square root here, it is square root.
No, we did v is equal to gr.
No.
gr minus 4gr is equal to gr. That's what we wrote.
It was v square equal to u square minus 2gh.
Okay, no, that one. Yes. So from that we derived u square minus 2g into 2r, u square minus 4gr is equal to 5gr minus 4gr.
Yeah. So that is the minimum, or you can say it is a critical velocity at the highest point. That should be the minimum velocity at the, we are talking about at the highest point.
Okay, then after that there will be this scenario if it will leave or if it will oscillate.
Yes.
Okay. And sir, can you say why did we do 5gr minus, I know how we got 4gr, why did we subtract it from 5gr?
Because u square is the minimum, u square is equal to 5gr is the minimum velocity of the projection.
Where did we write that?
We found it already.
We did not find it, sir. We didn't find. We just said u square is greater than equal to 5gr.
Yes. It should be greater than 5gr.
Okay. Or equal to it.
Yeah. So what is the minimum velocity? It should be 5gr square root. Okay. We are talking about minimum. It is always greater than 5gr square root. So what is the minimum? When the minimum is equal to 5gr square root. Okay. You will understand all the concept once you do questions.
Okay, sir. Let me
Got it?
I was writing it down, sir.
Everything is written here. Just see that. Okay, and this is the recap.
Are you going to upload this video as well online?
Yeah, it is online. We are live.
Okay, then I'll copy it from there.
Okay.
Yeah.
And even this is your, you can say it is brief description of all these. These are point we discussed. For a body looping the loop, the following condition hold good. VL must be greater than GR, VM must be greater than 3GR, VH must be greater than GR. TL is greater than 6 mg, TM is greater than 3 mg, TH is greater than 0. Okay.
Yes.
And we discussed V is equal to U square minus 2GH, T is equal to M by R, Basically, these two things will be asked. You need to remember this. V is u square minus 2gh. Okay, that is the velocity of the body at any particular point. Okay, T, that is a common formula for tension.
Yeah.
Only
in a vertical circle, right?
In a vertical circle, yeah. Only your u and h values will change. Okay.
In horizontal circle, tension would be equal to the centripetal force, right?
Yes. Got it?
So, why are we showing any centripetal force in vertical circle? Hello?
Yes.
Why aren't we showing any centripetal force in vertical
Yeah,
circle?
we have done the previous by the centripetal only.
But we took 10. Okay, so tension is equal to centripetal force.
There is a difference between tension and mg cos theta.
Yeah, I told that. Okay. So we're taking that difference every time as. Okay, we have everything.
See, in linear motion, what we were taking? In linear motion, the resultant force will be equal to ma.
Yeah.
But in circular motion, the resultant force will be equal to mv square by r.
Yes.
That is the only difference. Okay?
Okay.
Okay, so do you want to continue or we should have some break?
Any is okay. Whatever you find comfortable.
Okay, so if you are comfortable, then we can continue. Let's do the questions.
Okay. Okay, which question?
First one, 80.
80.
First of all, just try to draw diagram. Then it will be easy.
Okay.
Got this?
1 second. So I've only discussed about velocities at top. We didn't discuss about velocity at bottom.
We discussed it. Velocity at bottom will also be given by v square equal to u square minus 2gh. Velocity at the bottom is u. It is given.
Okay. Okay, we use that formula for this. Okay.
U is given. Velocity at the bottom is given.
We need to find the velocity. We need to find it, right?
Okay, you are talking about the question.
Yes.
Okay, one end of the string of length 1.5 meter is tied to a stone of mass 0.4 kg. Yeah, so mass is given as 0.4, radius is given as 1.5, g is given as 9.8. So the minimum speed required at the lowermost point. What was the formula?
V square is equal to u square minus 2gh.
What was the minimum velocity at the lowest point?
Okay, tension at lowest point is equal to m divided by r into v square.
We are not talking about tension. What is the minimum velocity?
But we only found it at the top. We didn't find it for the bottom.
Minimum velocity, we found it. It was 5gr square root.
Why?
Minimum velocity.
But that was the minimum velocity of the body to continue its loop.
Yeah. So
But
that is,
how is it at the? But we went for the bottom, right?
so that means the string does not slack at any point in its motion. That means it should continue its motion. So for continuation of motion, the minimum velocity must be 5gr square root.
So it doesn't matter if it's at bottom, it's at top. It
Yes.
will always be root 5gr
Yeah.
at any point.
Yes. Lowermost point. Lowermost point. We're talking about lowermost point.
No, but at any point, that's one should always be root 5gr.
Yeah, it should be greater than.
Yeah, greater than root 5gr. But while equating it, we use equal to, right?
Yeah.
Because we want minimum. And what was root 2gr then?
Root 2gr is a different one.
Okay, when it will oscillate.
Yeah.
Minimum and it should be greater. It should be less than root 2gr to oscillate, right?
Yeah.
Okay, so okay. There's no use of mass in this, right?
Yes. Mass will be coming into the picture once you will find tension.
We're not finding tension, right?
Yeah. In this question, we are not finding tension.
Okay. Root 75 is the answer.
Root 75. Yeah, right answer. It is 8.57 meter per second. Okay. Just do 81 now.
A body being 0.4 grade volume revolutions per second. The radius of the circle is 1.2 meter. Find the tension people.
Okay, just do the question. I'm just coming after drinking some water.
Okay.
In your test only that circular motion is coming?
Yes. The circular motion is coming. Yes, only circular motion.
Okay. This time frequency is given to you. In 81st question, frequency is given to you. That is two revolutions per second.
Per second, yes.
So by that you can find it omega, and with the help of omega you can find it V.
Yeah. Tension at lowest is equal to 79.
Yeah, right.
And tension at highest. So, when I found found out the velocity by using frequency. I found out the initial velocity, not the final velocity or something else, right?
Yeah.
So whenever you start, you find the initial velocity.
No. If the radius of the circle, find the tension when the body at the bottom of the circle, at the top of the circle. So, if we are talking about the bottom, we need to just take bottom velocity. If we are talking about the top, we need to take velocity at the top.
No, but if you find it out, then it will come as the same velocity for top and bottom, right?
Yeah, it will be different. It will be different because on what factors your velocity depends. It depends upon it. The formula is v is u square minus 2gh square root. Okay, that is the velocity, and u is the velocity at the time of projection. You can say at the bottom. Okay.
Okay, something else. I directly put the value of u in m divided by r into u square plus gr. I put it in that. And I got the correct answer.
Okay.
So assume that the initial velocity would be the same for both of them.
Yeah. That means bottom velocity will not change.
You just said that it will change depending on this.
See, velocity at each and every point is changing.
Yeah.
But when it was projected, when the u is the velocity by which it started its motion.
Yeah.
Okay.
No. What I'm asking is, whenever when I used frequency is equal to 1 by t and all that, I found out the initial velocity, right? U. That's what I'm asking.
Okay.
Or did I find out something else?
What will be the tension at top?
Tension at top. I need to find that out also.
If you're talking about top, so at this point, your tension and mg both will be downward.
Yeah.
So that should be added. They will be added to produce centripetal force. So T plus mg must be equal to mv square by r at the top. Okay.
Yeah.
And you can put v as r omega, so that becomes mr omega square. So that is T plus mg equal to mr omega square. Okay.
Okay. No, but so the question is not that. My question is, when you find it out using f is equal to 1 by t, so t is equal to 1 by f and v is equal to distance by time. What do you find out? The value which I got, was that the initial velocity or what was it?
Why initial velocity is required here?
No, to solve it, right? Because
Initial velocity is not coming into picture here.
No, not over there. In the original one, TL is equal to m divided by r u square plus gr.
Yeah, u square plus gr minus 3gh.
U square plus.
What was the tension at the top?
Yeah, u square plus, okay, minus 3gh, yes.
Okay.
Yeah. No, what I'm asking is, when I find out the velocity, that was the initial velocity, right?
Yes.
Okay, that's what I wanted to confirm. Yeah. The velocity I found out using the frequency was the initial one.
Yeah. You just directly put it there.
Okay, I was confused whether it would be the final velocity.
No. Don't be confused about the final and initial velocity.
It will always be the initial one. Like that.
Yeah. As we are talking about the top of the motion, then we'll take the velocity at the top. Okay.
Okay, only when we need to find out the final, then only we will think about all of that using v is equal to u square minus 2gh.
Yeah.
Right?
Yes.
Only then.
Yes.
Okay.
See, that's on the way.
Found it the tension at top.
1 second, sir. 4 by 12 into 65. We need to simplify that.
Okay, just use your calculator.
Okay. The answer is coming as 21.666.
How much?
21.7 from calculator.
No, yeah. What you doing? It is T plus mg equal to mr omega square. So what is the value of T? T is mr omega square minus mg. M is common. M is 0.4. So that is r omega square minus g. What is the value of omega?
So why are we doing all of that? Why don't we just put it in m by r into u square minus 5gr? You can use that as well, right?
Tension, yeah, you can use it that also, but is that u given?
We need to find u, right? We found it in the previous one as well. 1.
U is not given.
No, we found it using the 2 revolutions per second, right?
Can you find it by the 2 revolution per second?
You only told that we can find it, and I found it as well. Because time would be equal to 1 by f frequency. T is equal to 1 by f. And then you divide it by the distance traveled.
See, omega is 2 pi f. So 2 pi f is how much? What is frequency? 2 revolution.
Yeah.
So that is 4 pi. 4 pi is your omega.
Yeah.
V is r omega. Okay.
Yeah.
I just put omega only. Just put omega. Omega is 4 pi. Okay.
Okay.
But you can't say that it is its initial velocity. Initial velocity is not given here.
Okay, so why was my t lowest t? So why was my t lowest correct? But my t lowest was correct.
Yeah, it was correct.
How could I use that only? I used the TL formula. I put the value of u as 15.
Okay. So just put, see, what is the, you just have omega. So if you put omega directly into this question, you will find your answer.
One second. Can you explain that formula again? How did you get that T? Okay, it's the same one. Okay.
Yeah, that is the same formula.
But wait, there was no omega in that one. When did you do this?
T plus mg will be mv square by r.
Yeah, I understood that.
So mv square by r is what? That is mr omega square.
Okay, sir. Okay.
Okay. So I put that mr omega square minus mg. Omega square is, we found it. 1.2 into 4 pi square, that means 16 pi square, minus g is 9.8. So if we calculate it, we will get it 1.2 into 16 pi square, the value is 189.5. 189.5 minus 9.8. Okay, you are telling that we can do it by the formula we derived.
Yeah.
TH equal to m by r u square minus 5gr. Yeah, we can do it by that formula also. TH equal to m by r u square minus 5gr.
Yeah. Can we do it with this formula?
What is the value of u?
15.
Then what is the value of v?
Why would we find the value of v?
Is that given that it is starting its motion with u?
No. But like initial velocity is u, right?
Yeah, it is initial velocity, but is it given there in the question?
No, but it will always start it with u, right?
Yeah, it will always start, but is it given?
No.
You started your vehicle with some speed, but is it going with the same speed?
No.
So if I am talking about your speed is that much, then I am talking about that particular point.
Okay, so this one is only used when the speed is constant.
Speed cannot be constant in that motion. It is changing.
When the magnitude is same. I don't understand when do you use that formula and when do you use this one?
U is the initial velocity.
Yeah.
Okay. V is the velocity at any particular point. So the formula derived was V equal to u square minus 2gh. It is starting its motion with u. But as your height changes, your velocity will be changing. As it go up, velocity will be lesser. As it go down, velocity will be higher.
I don't understand that. When do you use this formula? TH is equal to m by r1. When do you use that one and when do you use this one?
If initial velocity is given to you.
Okay, you cannot find it by yourself and assume
Yes.
that it will be there.
Yes, 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 yes.
Okay. And when you don't have it, then you put t is equal to mr omega square minus mg.
Yeah, yeah.
Or whatever you find
Yeah.
using the free body diagram.
Yes, yes, yes.
But at the top, it will always be this, right? Mr omega square minus mg is equal to t.
Yeah,
And whatever it is at the top, it will be this.
yeah.
Okay.
Because at the top it will be added.
Yeah.
Okay.
1 second. So, sir.
And
can
at the
you also-
bottom, t minus mg will be equal to mr omega square.
Can you write that as well? That's what I was about to say.
See, at the bottom, that will be t and mg will be downward. So because of their two unbalances of these two forces, there will be centripetal force. Okay. So in that scenario, t will be more, mg will be less. They are in opposite direction. So that time t minus mg will be equal to mv square by r. Okay.
Yeah.
So at the bottom we'll get higher tension, at the top we'll get lower tension.
Okay. Can you, what's the value for answer for the highest one, sir?
See, you are just confused with the formula. Don't mug up the formula, just learn the concept. At the top, T plus mg will be equal to the centripetal force. At the bottom, T minus mg will be equal to the centripetal force. That's all.
Okay. Okay, at the top, because mg will also act downwards and the tension is also
Yeah.
acting downwards.
Yeah.
That's why it will be added together.
Yes.
And at the bottom, mg will act downwards and t will act upwards.
Yes. That's why it is subtracted.
Okay, that's why t minus mg will be equal to
Yeah.
Okay. Okay, thank you. Done it.
Done? Okay. Now, actually you're confusing yourself with the formula and the concept. Don't be confused.
Okay.
Just try to do 82 is 2 times.
Yeah.
Okay. Have I sent you that worksheet?
Which worksheet?
This one?
Which one is this?
It is motion.
Vertical. Yeah, it's in the vertical motion one.
Okay.
Let me check if it's correct. I didn't open it because
Yeah, I sent you.
Yes.
Actually, I sent you every worksheets I have. Yeah. You just need to practice. Now, whatever worksheet you sent me, that will be now understood. Okay, because there are the only concepts which we discussed here.
Did you see that worksheet?
Yeah.
Is there anything new or else which we didn't do in there?
No, nothing new.
All it's the same, right? What we did.
Yeah.
There's nothing else in there.
No. Same concept. Okay, we'll see it in front of you also. Okay. In one worksheets there are concepts with some questions, and in other only questions. Okay. So main thing is your basic concepts should be clear. Okay, when is your next exam?
My exam is tomorrow.
Yeah, it is tomorrow. For the next
Okay, it will be in 20 days.
20 days. What is the topic?
They don't give it to us yet.
Okay, because if you start it early, then we can control it.
Yeah. We'll tell when I get the.
Yeah. So get it timely and we'll start it timely so that you don't have any problem in the exam.
Yes. So. This will only happen when the T is equal to mg, right?
T equal to mg?
Yeah, only then it will move like that, right?
Yeah.
And they are acting in opposite direction.
Yes. You can answer in terms of pi also.
Okay, so in terms of that. Okay, understood. So this means mv square by r is equal to mg, right?
Yeah.
And the velocity of v is what we need to find.
Yes.
Sir, I
Yes.
did not, there was no pi in there.
If you are going to find, have you found velocity?
Yeah, root 25.
That means 5.
Yeah, root 25. Fine.
Now another question is frequency.
Okay. Okay, for that we will take the circumference of the circle as the distance. Right?
V is equal to r omega. So first find omega,
Okay.
then find f by omega.
Okay. So even this is like even the formulas which we had used for horizontal circle can be used for vertical circle.
Which one?
Even the formulas which we used for horizontal circle can be used for vertical circle.
Yeah, depends upon the condition.
Yeah. So in most cases, I think we can use it.
Yeah.
Is equal to 1 for n. Omega is 2. Okay, so now I put it in the formula. Omega is equal to 2 pi f, right?
Hmm.
1 by pi is equal to frequency.
Hmm.
Is it correct?
1 by pi.
Yeah.
Why it is 1 by 5? What is angular speed?
1 by pi.
No. V is 5 meter per second.
Yeah. And omega is equal to 2.
V is 5 meter per second. V is equal to R omega. Omega is 2 pi f. Okay. So f is V by 2 pi r. Okay.
Yes.
V is 5, 2 pi. What is R?
2.5.
2.5 meter. So 2.5. So it is 1 by pi. Yes. But the question is per minute.
Oh, minute.
It is
And
per
what
second.
is-
It is per second.
I didn't know that.
The answer will be in per second.
Okay, because I taken G in seconds.
Yes. Everything is in MCAS system.
Okay, yes.
So your answer will be coming into second. Per second it is 1 by pi. So in per minute it will be 60 by pi. These are some small glitches will be given to you. Okay. You need to find it. And in MCQs it will be also 1 by pi will be the option.
Yeah, that's the issue, and then you get trouble.
Okay.
Yes.
So just be careful about it. Whatever will be the answer of most of the student, that will also be given into the options,
Yeah.
because most of the student will tick that point.
Yes.
Okay. So the funda is just read the question carefully. Okay, now do 83rd.
88. Okay. Stolen as a complete Upward speed of the function is 0. The highest point of the system. Highest point of the system is tension at the highest point of the system. out mv square by r is equal to 0, right?
mv square by r equal to 0. Why?
Because the tension should be 0, right?
Tension at the highest point is 0.
Sorry, mv square by r plus mg should be equal to 0.
mv square by r is always the resultant force.
It's always the resultant force. Okay.
At the highest point, T plus mg will be mv square by r.
T, how do we find T? We need to find T. Okay.
It is given here.
I get quite confused in these questions.
Tension in the string be 0 at the highest point of the circle. It is already given.
So 0 is equal to tension plus mg. Is that what you're saying? I don't understand.
It is given that tension at the highest point is 0.
Yeah.
So the speed.
Okay, so mv square by r is equal to 0 and we find the velocity from it, right?
Just a moment. हेलो
देखिए कंप्यूटर सर आप घर पे ही होना ईशान आ रहा है
हाँ हाँ मैम ठीक है भेज दीजिए
ठीक जाओ ईशान
Yeah, what you're talking?
83.
83. So question number 83 is very simple. A stone of mass m is tied to one end of a string rotated in a vertical circle. At what speed of the ball will the tension in the string be 0? Tension is given as 0 and tension of the string will be 0 at which point?
At the
Highest point.
highest point, yeah.
At highest point, what is the velocity?
At the highest point of velocity. Yeah, that we need to find, right? So it would be it would be tension plus mg is equal to mv square by r, right?
Yeah, tension is given as 0.
Yes. So mg is equal to mv square by r.
Yes.
Okay. So someone was equating mv square by r is equal to 0. Let's say what. I don't know now I realize. Takes us to 4. Yes, sir. The answer is root 7.84.
Yeah, and that is 2.8 meter per second. Okay.
They're the same, right?
Yes.
Okay. Tension at the lowest point. Okay. 1 second. be the tension at the lowest point. Find the tension. So what will happen in this case? V square by R is equal to tension minus mg. Tension minus mg, yes. And we put the tension. We put the mv square by R 0. This will become 0.3 into 2.8 square divided by 1.2, sorry, 0.8 equal to tension minus 0.8.
Calculate it fast with the help of calculator.
Okay, sir. The value of 1 second. Yeah, okay. The value of tension is coming as 5.88.
5.88 is not the right answer. Okay, you can do it in, we know TL minus TH is how much? 6 mg.
Well, that is in that formula.
You can do it by this formula also, T minus mg equal to
Yeah, can you please show me that formula?
mv square by R.
Yeah.
Okay, so T would be, m is common, v square by R plus G. So T is, m is how much? 0.3 gram. Okay, 0.3 by 1000. V is 2.8. 2.8 square by R is how much?
0.8.
0.8 plus G is 9.8. What is the square of 2.8? It is 7 point something you were telling?
Yes.
7.4 divided by 0.8 plus 9.
7.84, sir.
7.84. Okay. So for easy calculation we can take it 7.8. Okay. 3 into 10 to the power minus 4. 7.8 divided by 8. 7.84 divided by 0.8. Just calculate it by calculator. How much?
Divided by 0.8.
Yeah.
It will be 9.8.
9.8 and 9.8 plus 9.8.
19.6.
19.6. The multiplication of 19.6 with 3 into 10 to the power minus 4.
58.8 into 10 to the power minus 4.
0.3 gram.
Okay, so I was wrong because I did not divide it by 1000. Okay.
No, still answer is wrong.
Okay, when your answer is wrong.
Yes.
What happens if you do by TL minus TH1?
Just a moment. So TL would be 6 mg because TH is 0.
Here.
So 6 into 0.3 into G is 9.8. So the answer would come
17.64.
17.64. That is the right answer. 17.64 Newton.
जो भी आप बना रहे हो वो इस पे कैसे आ रही है? जो भी आप बना रहे हो वो इस पे आ रही है।
Well, why is this method wrong? T minus mg.
It must not be wrong, yaar. T minus mg equals to mv square by r. Okay. Why it is wrong? Because this velocity we calculated, that velocity is at the top.
Okay, we need to find it at the bottom and we can't find it.
Yes.
Because
Okay.
we don't have any value about tension or anything else. We can't find the velocity at the bottom. We have only one option.
Oh yeah. Okay. That's why it is wrong. Because the velocity at top, we found it is 2.8. So we can't use it, the velocity at bottom like 2.8.
Okay.
Got my point?
Yes.
Okay. So these things you need to consider. Okay.
Yes.
And this exercise I already sent it to you. So please go through that exercise and do all the questions. Okay.
Okay. You didn't check the one which I sent you. There's nothing else, right?
Yeah, just I'll check you in front of you.
Okay. Thank you.
These are just question given in, yeah, this type of questions are given.
What about the theory? Is there anything else? In
Yeah,
that?
theory I covered everything.
No, the theory. Maybe there's. I think there was something else. That's what I'm saying.
No.
Can you check?
Yeah, I checked it.
Okay.
Okay.
Okay, maybe we didn't cover it yesterday and then check it. Maybe that's why. Okay.
Angular velocity of a minute hand of a clock means omega, you need to find it.
Yeah.
Okay. So you have the frequency for minute hand. What is the frequency of minute hand?
What's the frequency of minute hand? Where did this give the frequency of the minute hand?
Can't you find it?
No.
Why?
I don't know that.
How many rotation per second by minute hand? That
60.
that is the frequency.
Okay, so it will be 60.
60?
What do you mean? I don't understand what I say.
It is having one rotation in how much time?
Yeah, one rotation in 60 minutes.
60 minutes. Okay. So one rotation, that means 60 minutes is its time period.
Yeah. Okay, so do 1 by 60.
It is in minute. You need to find frequency in second always.
Okay, so it will be 1 by 60 into
60.
okay, 60.
That much
So it
second.
will be, so it will be 1.
Okay, so minute hand. It is talking about minute hand. So minute hand means minute hand completes a round in how much minute? 60 minute.
Yeah.
So its time period will be 60 minute. So frequency will be 1 by time period, so that will be 1 by 60 into 60, 1 by 3600 per second. Okay, is the frequency. What is omega? Omega is 2 pi f. So 2 pi into f is 3600. So that will be pi by 1800. So that are the only concept will be used here. Okay.
Yes, sir, there are new things, yes. Sir, I think there are new things in the theory. Can you go to that page which I sent you the document?
Just a moment. Okay. These are the theories.
We didn't cover angular displacement.
Angular displacement is what, yaar? That is very basic thing. Angular displacement means if you are in circular motion, so theta is the angular displacement.
Theta is angular displacement.
Okay?
Okay. Okay. Yes.
And omega is theta by t. Angular velocity is angular displacement upon time. Okay?
Yes. And sir, there's one more thing.
Yes,
Tangent.
yes, we will go. Angular displacement we covered, frequency, time period, angular velocity, relation between V and R, V is equal to R omega. We covered everything. Okay, instantaneous and angular acceleration, average angular acceleration. So
What's that? We didn't do that.
you just told me about NLM portion, that is very basic things.
Yeah.
Okay, you sent it yesterday only.
What is angular acceleration?
Angular.
Okay, angular. Okay, so it will be the angular velocity divided by time taken.
Yes.
Okay, sure.
Okay.
It wasn't something else. Okay, what's tangential acceleration?
Yeah, centripetal acceleration also.
What's tangential acceleration? Because of that.
Tangential acceleration, the change in tangential velocity divided by time, that will be your tangential acceleration.
Tangent to what?
It is a circular motion. So every time once you are finding its instantaneous velocity, that will be tangential. Along to the circle it is. Every time your velocity is, let us say you are finding velocity at this point, so that will be tangential velocity. It is said to be tangential. At this point the velocity will be like this. So it is always tangential to the circle.
Okay, so instantaneous velocities or tangential velocity?
Yes. Okay. So uniform and non-uniform circular motion we already discussed.
Yes. We did non-uniform as well.
Yeah.
What we did today was non-uniform, right?
Yeah, it is non-uniform.
And what we did till yesterday in the horizontal one was uniform, right?
Horizontal was uniform, yeah. That was going
And
with the vertically it is changing its velocity at each and every moment.
Even in horizontal is changing.
No.
right?
In horizontal it is not changing, it is uniform.
It's magnitude, right?
Yeah. Magnitude is not changing, but its direction is changing every time.
In horizontal.
Yeah.
And in vertical, both are changing.
Yes.
Okay, just
Okay. So these things we discussed.
sir, can you go down 1 second? Down. No, not like that.
Yeah,
go to page number 58.
If this type of question is given to you, are you able to solve these questions?
The angular velocity of
It
and the instant when the angular acceleration.
it will be done by differentiation.
Yeah, it will be differentiate the equation to find the angular acceleration. We equate it to 0.
Okay.
Yeah.
These are this type of questions only.
We integrate angular acceleration to find angular velocity.
Yeah, circular turning on road we covered it.
Yes.
Banking also covered.
Yes.
Friction and banking on both.
We didn't do it with friction.
Yeah, if friction is there, then we'll consider it.
Subtract it.
Yeah, that is simple thing. Okay. Conical pendulum, the same thing. Okay, death valve rotor, we already discussed it. It is circular motion. Vertical circular motion we discussed today. Condition of oscillation and all we discussed today. Condition of looping the loop we already discussed. I don't think
But
that
there's still, can you go to page number 58?
58 is not there.
No, this is 16, 2 pages. 58, sir.
58 is not there, yeah? Only 19 pages are there.
No, in this one, there's a page number 60, right? Like that 58.
Okay, 60. Yeah.
58. Can you go to illustration number 12? Yes.
Yes. What is bothering you in this question?
I don't understand this properly.
You don't understand it because you see that entire thing. You just see the question, make a diagram, okay, then you will have your answer. Don't think about the entire thing, that where this n cos alpha and sin alpha. You just bothering about n cos alpha and sin alpha.
Yeah.
Okay, don't think the solution of the question before doing it. Just
Okay.
try it before. Okay, then I think it is 2 hours, more than 2 hours.
Yeah.
Okay, so I think it is sufficient today.
Also, when you need to include friction, you just put F is equal to UR and just solve it, right? Opposite to the direction of motion, right?
Yes.
You'll always should opposite. If the object is moving like this, the friction will move like this.
Friction is always subtracted. Always it will be subtracted.
Okay.
Okay.
Always subtracted.
Yeah. Okay.
Never added.
Yes.